Next time you're walking up a high-rise stairwell or parking your car in a massive multi-level garage, take a second and look up. See those thick red pipes and heavy-duty hose valves? Well, those aren't just everyday plumbing. For a firefighter in a crisis, those pipes are literal lifelines. So today, we're unpacking the document that makes all of that possible. In this explainer, we're not going to treat this standard like some dusty bureaucratic rulebook. Instead, we're looking at it as a living, breathing blueprint for building safety. This right here is the 2024 edition of Nfpa 14, the standard for the installation of standpipe and hose systems. When engineers, architects, and fire marshals sit down to design a major building, this is the exact text they turn to. It is the absolute ultimate authority on how to get water from the ground up to the very highest point of a skyscraper, especially when every single second counts.
Here is our roadmap for today's explainer. 1. What is Nfpa 14? 2. A century of evolution. 3. The 2024 edition updates. 4. Navigating the blueprint. And 5. Administration and rules. Let's get right into it.
Section 1. What is Nfpa 14?
If you want to cut right through the heavy engineering jargon, Section 1.2.1 hits the nail on the head. It says, and I quote, "The purpose of this standard is to provide a reasonable degree of protection for life and property from fire through installation requirements for standpipes and hose systems based on sound engineering principles, test data, and field experience." It all anchors back to one core human element: keeping people and property safe.
But here's a really crucial point. You have to understand the specific boundaries of this standard. As Section 1.1 spells out, Nfpa 14 covers the minimum requirements for the installation of these systems. It dictates how they're designed, sized, and actually built. But, and this is a massive but, it does not cover the periodic inspection, testing, and maintenance of those systems once they're already up and running. That whole process falls under a completely different standard, Nfpa 25. Nfpa 14 is just all about getting the bones built right the very first time.
Section 2. A century of evolution. This code didn't just magically appear out of nowhere. It's actually a historical timeline of really hard-learned lessons. The standard dates literally all the way back to an initial report in 1912. I mean, just think about the high-rises being built in 1912 compared to today. The code has had to constantly adapt based on real-world field experience under incredibly intense fire conditions. We're talking major milestones, like a total reorganization back in 1993 to make the thing actually user-friendly, and then a big year 2000 update that brought in rules for hydrants and hose houses. Fast forward into the modern era, and you really see the code trying to keep pace. In 2003, they added some super complex hydraulic calculation requirements. By 2013, they were fine-tuning clearance requirements and adding heat tracing rules for freezing environments. And then check out 2019. This is where the code truly meets modern tech, adding rules for automated remote monitoring, plus specialized chapters for maritime standpipes. It's just a constant game of catching up to the way we build our world today. Section 3, the 2024 edition updates. So what is fresh in 2024? Honestly, usability was a huge focus. They completely reorganized the book to line up with Nfpa 13, which is the sprinkler standard, because engineers are constantly using them side by side. They also carved out a brand new chapter just to consolidate scattered general requirements. And crucially, they did a massive rework on Section 10.5, which deals with vertical standpipe zones. High-rises have incredibly complex vertical pressure zones, right? So the committee reworked this entirely to ensure it's much easier to digest, which ultimately guarantees an adequate level of safety no matter how tall a building gets. But I've got to give you a fascinating little reality check here. Right at the front of the book, there's an alert notice about Tentative Interim Amendments, or TIAs. Basically, this tells users that the standard can be superseded literally at any time. If a tragic incident happens tomorrow and engineers realize a rule needs to change right away, the Nfpa doesn't just sit around waiting for the next publishing cycle. They issue a TIA. It's ultimate proof that this is a living, breathing document constantly reacting to new safety data. Section 4. Navigating the blueprint. Look at the table of contents for a second. It is dense, 16 chapters, dozens of subsections, annexes, indexes. Honestly, it looks pretty overwhelming at first glance. But don't worry, we're going to chunk this down into functional buckets.
When you break it apart, the flow of information is actually incredibly logical. Think of it kind of like building a house. First, you have the admin and definitions in chapters 1 through 3. That establishes the ground rules. Then chapters 4 through 6 cover the core requirements and water supply, because, you have to know where your water is coming from before you start building. Next, chapters 7 and 8 list all the specific system components and hardware, the physical pipes, valves, and fittings you're going to use. Then comes the heavy lifting. Chapters 9 through 11 cover the actual installation rules and the complex hydraulic system design. And finally, chapters 12 through 16 handle final system acceptance testing, plus those specialized rules for things like buildings currently under construction or maritime systems. It's a perfectly chronological journey from a raw concept to a final test.
Section 5, Administration and Rules.
Okay, so if you're managing an older facility, Section 1.3 is your best friend. It covers the concept of retroactivity. The big question is always, does a 2024 standard mean you have to rip open the walls of a building built in 1980? Generally speaking, no. For new installations, sure, these rules apply directly. But for existing facilities, the 2024 rules are not applied retroactively, unless a specific local official determines that the existing setup presents an unacceptable degree of risk.
Also, engineering is a global game, right? So the standard has to bridge the gap between traditional U.S. measurements and global units. Table 1.5.1 explicitly incorporates the modernized metric system, or SI. But because of common industry practices, they also allow for units like liters for fluid capacity and bars for pressure. They provide the exact conversion factors so engineers across completely different regions can precisely design the exact same life-saving systems without making any math errors.
Now, earlier I mentioned a local official deciding on retroactivity. Well, Section 3.22 formally defines this as the authority having jurisdiction, or at the AHJ. This is a critical concept to grasp. The Nfpa writes the standard, sure, but the Nfpa has absolutely zero power to police or enforce it. They are strictly the authors. The AHJ, which could be your local fire marshal, a building inspector, or a state agency, that is the actual legal entity responsible for enforcing the code and approving the final installations.
And that flows perfectly into the legal disclaimers right at the front of the document. The Nfpa makes it crystal clear. They facilitate a consensus process among experts, but they do not independently test or verify the data themselves, and they definitely do not accept liability for property damage or injury. They explicitly state that users of the standard have to rely on their own independent professional judgment and consult all their local and federal laws. In short, the Nfpa provides the expert blueprint, but the responsibility of safely executing that blueprint, that lies entirely with the engineers, contractors, and local authorities.
I want to leave you with this really cool provision from Section 1.2.3. It essentially states that nothing in this standard is intended to restrict new technologies or alternate arrangements, as long as you don't lower the level of safety. We've already seen remote monitoring enter the code. So with all these crazy advancements in AI, smart buildings, and automated water flow sensors, how is emerging tech going to shape the next edition of Nfpa 14? The blueprint is constantly evolving, and honestly, that is a very good thing for public safety. Thanks for joining us for this explainer.